In this tutorial, we're going to discuss solid principles, what they are, and most important, why we should use them. So as a very short introduction to the topic, SOLID is an acronym for 5 design principles that are used in object-oriented programming to make your code more flexible and easier to work with. So these principles are single responsibility principle, open-close principle, list of substitution principle, interface segregation principle, and dependency inversion principle. We're going to cover all of them in detail in the next videos, but for the moment, before we get into these details, let's take a look at why these principles are so important and what can happen to your project if you're not going to understand and use them. So let's imagine that you start writing some new food ordering application totally from scratch. So in the beginning, you only want to focus on its most basic, most fundamental functionalities and workflows that would allow customer to place the order. So these functionalities will be menu and checkout. And now, because you want to start making money from this application as soon as possible, so it means that you want to build and send live this application as soon as possible as well. And because of that, you don't really care that much about any specific design or architecture for the code of your application. You just want to quickly write your code just to make things work. So you write these most basic functionalities. Let's say you're done after a week, you send the application live, customers start to place orders, application is working, so far so good, everyone is happy. And now it's pretty important to notice that because our application code base is still relatively small at the moment and it's just not a lot of things going on. So it means that first, you clearly see what is going on. It means that you know what each function is responsible for and how the data flows within the application. So it's pretty easy for you to spot any potential issues. And the second thing, code is really flexible and easy to maintain. So new improvements can be done pretty fast and it's really easy to make any fixes. Alright, so after a couple of days, you come up with an idea that you want to add another functionality into the system. Let's say your food ordering application so far only offered users a possibility to place orders for collections or deliveries, but now you want to offer table service as well. So your customers can sit at a table in your restaurant, open up the app, place the order, and the food will be delivered directly to their table. So you start looking into the code to see how you can implement it. And the first thing that you notice is that if you would like to introduce this new functionality, you would need to rewrite a little bit of code in menu workflow and a little bit of code in checkout workflow as well, simply because your current design was not that good and you found it pretty difficult to make any changes to it. So you start rewriting your code. And it turns out that it took you like 4 long hours to rewrite these few pieces of code. And what does it mean? It means that you spend that much time just preparing your application for making any new changes to it. You didn't progress with new functionality yet, at all. Okay, so afterwards, finally, you start writing this new functionality you were thinking of, and it takes you like 8 hours. And now you remember what happened earlier on. Because of previous bad design, you needed to spend 4 hours on rewriting your code just to add some new functionality to it. And because you're smart and you don't want to make this mistake once again, now you actually use some better designs when building this new functionality, and generally did your best to organize your code in a much better way. But there's an issue. You know you just couldn't make everything perfect and fix everything, because it would mean that you will need to rewrite way too much code that you wrote in the beginning. And you just don't want to rewrite the entire application from scratch now because it would take too much time. So you're kind of left with some good design but built on top of bad design. Okay, so finally you updated your application with this new table service functionality and users are loving it. However, after a couple of weeks, you start getting more and more comments from users that your application is missing very important functionality. Normally, when they order food in store, they can see all kind of deals like 2 for 1, 50% off on Mondays, or buy one, get one free, but they cannot see it anywhere in your app. So instead of ordering from your app, they go to your competition. So you start losing sales and customers. You understand that this functionality is really important and you need to get it added as soon as possible. So you quickly look at your application code once again, and you realize that adding this new functionality would require rewriting quite a big chunk of all previous functionalities that you just done recently, simply because there are still many leftovers from bad design that you had in the very beginning. And now you generally feel that it's getting more and more difficult to add new functionalities into the system and things could easily break because of its bad design. So probably the best thing to do would be to actually spend some time on rewriting everything from scratch. So the code will be much cleaner and more flexible. But at the same time you realize how much time it would take and you simply don't have that much time. You need to act fast because you're losing your customers and hence money. So now you need to answer a pretty difficult question. Is it better to add another hack into the system just to make things work for now? Or would it be better to actually rewrite quite a big part of your application just to make things easier to work with, but for a later time? Yes, it is a difficult question, and most of the time such big redesigns don't really happen. The main problem is that the application needs to keep up with constant changes and new requirements, and there is just not enough time or money to be spent on rewriting in the entire code base just to make things easier to work with at a later time. So eventually the design gets worse and worse over time, and it's becoming more and more difficult to keep changing and improving our application. So you end up losing customers, time and money, simply because you cannot keep up with all constant changes and new requirements for your application. So now, coming back to our very first question from the beginning, what are solid principles and why we should use them? Solid principles help us in understanding how to make our code more flexible and maintainable so we can avoid all these issues that we just discussed so we don't end up wasting time and money. So how exactly these principles help us? We're gonna discuss each of them in detail in the next videos, but before we get into that, let's understand how exactly you can spot that our design is going in the wrong direction so we can act and fix our code before it's too late. So how can we know that our design is getting worse and we can end up having issues sooner or later? There are 4 primary indicators that we can look out for: rigidity, fragility, immobility, and viscosity. And we're gonna cover each of these in the next videos, and afterwards we're gonna proceed with explaining actual solid principles one by one, so we will have a better understanding on why we actually use them. So that's it for this video. Thank you for watching and see you in the next one.